So welcome. I don't know how much connection is going to happen with all so much happening in the hall, so much noise, but we will try our best. So when we often talk about, I think we'll do more extempo rather than trying to go by whatever exchange we had because there's a lot of distraction. So my question is, all three of you have had a very deep and long connection with data center ecosystem. So not that any one of you has worked with a data center operator, but you have been associated in the whole 360-degree value chain and have played a very crucial role in your own capacities in different aspects. You come from mostly cooling background, HVAC. You come from sustainability, if I'm right, right? And you come from overall designing. So you create the heart. So, madam, I will start with you because obviously, if you look at the life cycle of a data center, first starts with designing. And I'll go a step before. Are you involved also in land identification for a data center? How complex? I mean, I know that finding the right property, right land for data center can possibly take you much more effort, much longer than even building a data center. So, as a consultant, you get a piece of land, then you get a briefing from a client as to what do they want to do. So you try and do a size fit of that, looking at the capacity, the productivity of the land, the plot size, then you look at what density, and then everything starts. So would you help us maybe give a kickstart of how would you start?
Sure. So good evening, everyone. Firstly, I would like to thank W.Media and all other associated partners for organizing such a beautiful event. Well, your question is a very good question. Regarding the feasibility study, yes, we do that. As a designer, we start with the site feasibility study. So it includes everything, not only the climate, neighborhood context, and then the transportation, fiber routing, and also the power feasibility. So we do all the study. Based on that is whether this particular land is capable enough to accommodate this much of IT load. So
Right.
that's how it is being derived at. So in fact, we do a test fit study as well. So we do a site analysis and work on a test fit to check whether how much of IT load we could accommodate in that building.
Right.
And then that has been proposed to the client for them to analyze whether this site could good enough to proceed or not.
Right. So what is it? Do you get into some kind of situation, chicken or egg first? Because many times client will say that I want to fit so many megawatts in this plot. I
Yes.
want to fit so many buildings, and your land possibly doesn't support that. So do you get into?
Definitely. So this is a very common factor. Sometimes we end up getting a very narrow site where we will not be able to accommodate whatever the load they are talking about. So we tell them that the realistic figure, like how much IT load can be accommodated in that particular site. So it's up to the client whether they can proceed or they can look out for some other site.
Right. So, Shashankji, coming to you, if you pick up one thread from what Jayanthy ji said, it is all about trying to do maximum from the minimum, right? Everybody wants to pack maximum megawatt in the land that you have. So in this quest of doing maximum, we had 3 kilowatt per rack uh, density, then we reached 20, now we are at 40, 50 even for cloud. And then when we go to AI, we start talking from 100 onwards, and God alone knows we are talking about 1 megawatt per rack. So from sustainability point of view, this drive to do more, this drive to get maximum out of minimum, how do you see, where is it taking us?
Hi everyone. Uh, Sandeep ji, see, right now everybody is going, let's say, bigger and bigger. Everybody is talking about the bigger campuses, right? But from the perspective of where we are right now, and I see how the industry will shape out in the future, that will not going to be the bigger and bigger. I think it is going to be more on the distributed manner, and that is where the future is. Because we need to understand why right now people are talking bigger and bigger campuses, because of the only in one reason, because they all has to right now assemble lot of chips, and from there they have to train lot of AI models. The moment the model will be finished, let's say right now people are training the model on billions of data set. So once the model will be trained, then what will be the purpose of the bigger campuses? Of course, they will be there. They will be training on the different skill set, maybe in the medical, in every sector, right? But that is not going to be the actual use cases for the all the audience or all the user base. So from my perspective, it is going to be the smaller modular base or the container based data centers that will run as edge centers. That is what a lot of expert I was saying. They were talking also about the edge computing and edge centers. That is where it lies, that that is when only it can be sustainable, because with the smaller centers you can run even with the small power. You don't require the huge substations to connect it to it. You can take even the smaller container of the data center to directly to, let's say, wind power farm, and even with the small excess of the energy you can run that center, because that centers don't require a model training. That centers is only AI inference. And for running the AI inference, you don't require big and big and big. So I think that is the way forward, and that is way forward to being sustainable also.
Right. But isn't there a factor that anything when you get a critical mass, uh, you get more efficiency? So from that point of view, just asking a question, kind of contradicting your opinion to get the best out
Yeah.
of that, isn't the scale, the mass always better efficient? So how are you saying that smaller data center will be more efficient than the larger ones?
There is a very like real life example. If you see, let's say in the Chennai, we had a typhoon few years back. Imagine if there is a one substation that is running the electricity for whole state. Let's say example, right now the war is happening in the Gulf market, and if there is a one data center get attacked or one data center get affected, the whole system break down. So you need this distributed system, not just for sustainability but also to working it. So this makes logical sense also, not just for the sustainability point of view. And other side, like you can't deploy the whole energy in one mega stations and wait for it that it is going to solve every problem. Because inference, like for asking one question and answer for chat GPT, you don't require the mega center. Why you will be then setting up for that? That's what I feel.
Right. My view is training is not getting over in any near future, and inference is definitely there. But anyway, that's a discussion for some other day. Coming to you, Vinodji, you come from cooling and particularly air background. So days of air cooling are over. Is that, or how do you see it with liquid cooling and high density GPUs? How do you see future of air cooling? Another thing is from sustainability point of view, one 10 megawatt data center takes water which is equivalent to enough for drinking of 2 lakh people. That's the kind of water requirement.
Yeah.
We have come down in the last 10 years from PUE of 1.6, 1.7, which used to be very common by 2012-13 to about 1.3 now. But that has all happened at the cost of water.
Yeah.
We have used water and water and water to bring down PUE.
Right.
Now we have come to a point where we are at a brink where we have to understand that water is not infinitely available. We have to save water. We are not even talking about carbon yet. We are only talking about PUE. But PUE and carbon have nothing to do with each other. So how do you?
Yeah. So you asked me two questions. One was whether air and water cooling are going to be, whether air cooling is getting extinct from data centers. No, I don't think so, because data centers, apart from taking away the heat which is generated at the chip, is also required to be in a controlled atmosphere where not only temperature but humidity, pressurization, and the contaminants in that air, they need to be controlled. Otherwise, data center cannot function. See, we are not only making data centers just on the energy efficiency alone, but they have to be made resilient enough so that when all these kind of situations prevail, the data center should not go down, or the downtime should be kept to the bare minimum. Now, under various tiers, 1, 2, 3, 4, tier 4 talks about just 2 hours of downtime in 8,760 hours. So, all the complete environment has to be seen holistically. So that's where the proper air engineering comes into play.
Right.
This is one. Second point, you talked about PUE at the cost of other. So now, till now, PUE has been like a North Star.
Correct.
Data center PUE, if you are able to control properly, that means you have achieved something big. But then I think time has come now to see whether PUE reduction is coming at the cost of water or carbon.
Yes.
So I would introduce two new terms here, WUE
Yes.
and CUE.
Right.
Carbon usage effectiveness, water usage effectiveness.
Absolutely.
All these three factors have to be balanced properly in order for the data center to expand. And as government of India is now giving a fantastic thrust to data centers in India, and we are not going to make only data centers for data in India and processed in India, but India is going to become global data center hub in near future. So we have to balance all these 3-4 aspects, and we have to see that the data center design should not be only on the energy, but how much we are taking from the planet. The less we take from the planet, the more sustainable and the efficient data center design becomes.
Right. Absolutely. Very, very valid and very useful insights you have given. Jayanthy ji, now picking up a thread from what Vinod ji said, how do you see desalination as one of the supporting solutions to this problem? Is that a sustainable solution? What happens in case you don't have access to sea? For example, you have a data center in NCR. You have it in Mumbai, at least you have sea. Again, how far is sea from your data center location? And if you desalinate water, how do you transport it up to there and back? These are all the questions. So from a design consultant point of view, how do you see that as an emerging solution to support the cooling needs and harm the environment as less as possible?
Well, so if you ask me, see, I'm a lead certified professional. If you ask me, data center itself is not a truly sustainable project. Why? Because this is something irrespective of whatever liquid cooling option, you go with different type of liquid cooling option, whatever it is, the energy consumption is significant over here.
Yes.
So we cannot call this as a truly sustainable. First thing, I wanted to highlight this over here. When do we say it's a truly sustainable? Mainly because when a building is a net zero building. Can we do a data center which is net zero building? Not feasible. Maybe we can go near to the next net zero. But we can see different type of other buildings which is a net zero building. A school building can become a net zero, hospital can become, an IT office can become, but not a data center. Coming back to your question of water. Water is something like a tropical climate, we have a scarcity of water. Desalination, yes, we can do, but the cost for desalination is also a factor into it.
Correct.
So that is the reason why now most of the people are going with the sewage water, treated sewage water, which is again treated and that's been utilized.
Right.
So that is one option. But desalination is definitely going to cost you expensive. That is one thing. And your carbon, of course, you need to also look into the aspect of carbon, embodied carbon.
Right.
So the carbon footprint, which is like taking the water from all the way from sea and then it has been converted and then it has been utilized, that factor also needs to be considered into it.
Right. Very well said. So you also talked about data center, India becoming data center hub for the world. So if we go back to the union budget of government, the latest union budget, there were a couple of tax incentives specifically for data center. One was 20-year long-term benefit. The second was related party safe harbor. Both were intended to make India as a hub for data center of the world, which means until then we were talking about 20% of total data of the world being India, only 3% capacity, DPDP, data sovereignty. So it was all about Indian data in India. Now we are talking about the whole budget was made, like you said, to make India as a preferred option to run the data center of the whole world. Now, if you look at US on the other side, so it is important if we want to do that, if that is a hunger direction, then how do we make sure that impact of that is minimum to our environment? We don't want to import a problem which nobody else wants and then sync with it. If US communities do not want data center, it is for a reason. You see a lot of such protests in APAC. You see a lot of such resistance in Ireland and other parts of Europe. So if there are reasons why they don't want data centers, and we are happy to welcome them, what do we need to do to make sure that we don't take a problem on our head and sync with it?
Hello. You rightly said that the data center, government of India is encouraging data centers, and India government wants India to become the hub, global hub. India as a global hub for the entire world's data to be processed here. But now we have to look at two, three things. One is what is our infrastructure readiness? Like if we are talking about power, I mean, all data centers are very much, power intensive. So how our grids are, positioned in terms of availability of power. Then second important thing is how sustainably we are able to use other resources, specifically water. So these two things become the driving point for India if it has to grow into the data center exponentially. In next 5 years, we are talking about growing 5 times of what is today's capacity. So in that context, the designs of the data center have to become very, very smart. The entire cooling strategy has to be looked at very critically in terms of adopting technologies which are not power hungry or power intensive. Maybe talking about indirect evaporative cooling technology, which reduces the which reduces the load on the mechanical cooling significantly. We have to make sure that the environment that we are creating for data center doesn't allow for outside air to be, coming in and bringing problems of humidity and moisture management. We also have to look at generating water from, the moisture which is available in the air. Like Chennai is an excellent place where, there is so much of moisture available in the air. So we have to look at those technologies, and at the same time we have to keep, going in a disciplined and professional manner. So I would just sum it up with a sentence that India can, become a data center global, but then India can also show to the world that how it is done responsibly and with, sustainability practices. Thank you.
Yeah, thank you. That's a very positive outlook as you ended that conclusion. I mean, came to that conclusion. So, given that we have 5 minutes, would you like to add any aspects to whatever we have discussed? Maybe do a wrap-up note.
I would also like to add few.
Yeah, sure.
Okay. See, we talked about carbon emission, but maybe we did not discuss more in detail. For generating 1 kilowatt of IT load, okay, we need about 9 tons of carbon emission is being emitted into the atmosphere. But how are we going to mitigate that? That's going to be a big challenge for us. This is only the operational carbon emission of the data center. Apart from that, there is also a construction carbon emission. That is a different aspect. But this is something which we all need to think about it. And if it is going to be 9 tons of carbon emission per year, it's a huge number. And to mitigate that, I don't see any other thing except like planting more trees. And planting more trees. We have some Indian trees like Ashoka, Badam, which can absorb around 50 to 60 kgs of carbon per year. But that is again, one tree can absorb 50 kgs. To accommodate 9 tons, imagine the amount of land you need to plant. So this is something that everybody needs to think about it. Though we are all into the designing of a data center, developing and everything, when it comes to environmental aspect, there is a challenge.
Okay. Uh, I think to summarize the discussion, anyhow, we are now ending to the session. There is a few things which I feel we that is well known that all the data centers have two requirements. One is power, one is water. So if we can manage both as better way, that is what will solve the problem for everyone. So for a power, I think what I was trying to convey that, okay, maybe the distributed model would be the one model which can be utilized, that rather than everywhere just thinking about the big, we can go on the distributed model, not right now, but later stage, and can take the smaller containers in the data centers to the power and can reutilize as much the excess of the power by the solar or by the wind powers, what is available, let's say in few states, in Tamil Nadu, in Rajasthan, in Gujarat, and these locations. Second, for a water also, there is a lot of ways to optimize. We can't stop it because that is the key for containing the server cool. So even if we go on the liquid cooling system, there is some way to optimize it. One is that we go on this closed loop water supply, where through the one closed pipe, we can reutilize the water in circulation so that we can try to make the net zero wastage of the water. Second, rather than using the groundwater, we should focus on the grey water, which is like from the industry or from the rainwater, this kind of things we can do it. Apart from that, making it fully sustainable, then we have to see the complete supply chain. And for making the supply chain sustainable and efficient, that will require a lot of work to do right now. But I think a lot of companies, including us and a lot of people, for our client, we are trying to calculate from now itself that if we can provide supply chain calculation for the carbon emissions and all this for data center client specifically. So I think these are the few things can take a step up and can solve the problem for now. That's all. Thank you.
Yeah, I think we are done with our time. So thank you very much. Very, very deep, insighted views based on your long experience. Thank you very much.